In this video, let us see about the number system conversion. That is, from any radix you can convert to any other number system. First, let us see about how to convert a decimal number to binary number, octal number as well as hexadecimal number. First, let us take a decimal number of 46 and we have to convert it into binary. For any conversion from decimal to any number system, just apply successive division method or repeated division method. Only thing is that if you are converting into binary, divide by its base 2. For octal conversion, you have to divide by 8. For hexadecimal, divide by 16. Now take this 46, we are going to convert to binary. So divide by 2. So what you will get? 23 and remainder is 0. Again divide by 2. You will get 11 as quotient and remainder is 1. So always mark the remainder separately. So you repeat this process till you get 1 here. Okay. Then once you get a 1 here, your process is over. Just mark an arrow from bottom to top. So you are moving from bottom to top. Now the equivalent binary value is 1011110. So this is our equivalent binary value for this decimal number 46. Now let us find the equivalent octal number for 46 decimal number. So divide by 8. So 8 5s are 40 and the remainder will be 6. So we cannot divide 5 again. So let us stop with this. Now the resultant octal value is 56 for a given decimal number of 46. Now we will find the equivalent hexadecimal number. For hexadecimal number, we have to divide by 16. So divide by 16. So 2 times you will get the quotient and here remainder is 14. But 14 is not a hexadecimal number. You have to find the equivalent value for that. So what is the equivalent alphabet for 14? You see this table. Here the equivalent alphabet is E. So instead of 14, you have to write E. So 2E is the answer. So the equivalent hexadecimal value is 2E for 46. Next we will see how to convert a binary number to decimal, octal and hexadecimal number. Let us take this binary number and convert it into decimal number first. So write the binary number, write the weighted value for each bit. So this is the least significant bit. For this the weighted value is 2 power 0. So it continues like this, 2 power 1, 2 power 2, 2 power 3. It keeps on going like this. So what is 2 power 7? It is 128. 2 power 6 is 64. 2 power 5 is 32. So we know the remaining values. Now how to find the equivalent decimal value? You multiply this number, this bit 1 into 128 plus 1 into 64. So here it is 0. So you can skip these two and again you have 1 into 8. Then 1 into 2. So total it you will get 202. So the equivalent decimal value for this binary is 202. Next we will find the equivalent octal value for the given binary number. So octal and hexadecimal conversion from binary is very easy. So you have this binary number. For octal, what is the total number or the base of octal number is 8. it means that maximum it can have only 3 bits, 1, 1, 1. So let us take this binary number and combine 3 bits together. Always start from LSB position. So here 3, again 3, and again you can take 3, or if you are taking the third bit it will be 0. So you can leave that. Always start from LSB position. Okay. So what is 0, 1, 0? 2. So you can, if you want, you can refer this table. What is 0, 1, 0? It is 2. So it is 2. What is 0, 0, 1? It is 1. What is 1, 1? It is 3. So the equivalent octal value for this binary number is 312. Next we have to find hexadecimal number. Hexadecimal is also very easy. Here totally we have 16 numbers. So the maximum number is 1111. It means that it can have 4 digits. So combine 4 digits from LSB position. So here 4 and again 4 bits are there. So you find the equivalent value for this one. 1010. 1010 means it's A. Again 1100 means 1100 is C. So the equivalent hexadecimal value is CA. CA. Next we will see the next conversion from octal to decimal, binary and hexadecimal. When you are given any octal number or hexadecimal number, always first convert to binary. It will be very easy. Then you can convert to decimal. From binary to decimal conversion is easy. So always first convert the given octal number to binary number. So now we have octal number of 63. Now what is the binary equivalent for 3? It is 011. So here it is 011, and binary equivalent of 6 is 110. So you write it like this. So you got the equivalent binary number 110011. So you got the equivalent binary number. Next we will find the equivalent hexadecimal number. Now we know the binary number. To get the hexadecimal number, same number, already we know how to convert a binary to hexadecimal. Okay. So you are splitting into or combining the 4 bits together. So combine 4 bits together. So it is 0011. Again it is 3. Here also you have 11. So it is 3. So 33 is the equivalent hexadecimal number. Next we have one more thing to find out, that is to find equivalent decimal number. So from binary we are going to convert to decimal. So first write the binary number. Write the weighted value for each bit. So 2 power 0, 1, 2, 3, 4, 5, because only 5 bits are here. Now find the equivalent decimal value. 32 plus 16 plus 2 plus 1. These 2 bits are 0. So add it, you are getting 51. So the equivalent decimal value is 51. Next we will see about hexadecimal to other radix conversion. The given hexadecimal number is 183. Let us write it here separately. So this is a hexadecimal number. So you write the equivalent binary number in terms of 4 bits. 0 for 1 I can write 0001. Here it is A is given. A means equivalent is 10 in decimal. So how to write? So you write this 8421. How you will get 10? Here 8 should be 1 and this second bit also, if it is 1, totally 8 plus 2 you will get 10. So that corresponds to A. So 1010. If you are not aware of this one, just see the chapter 1 video. There I have explained clearly how to find this conversion value. Then we have the third bit 3. So for 3 it is 0 1 1. So you can see here last 2 bits are 1. So in 8421 this is 2 is 1, this bit and this bit are 1. Totally if you add it, 2 plus 1 will give you 3. So this is the equivalent binary value. So this is binary value. Now let us find the octal value. For octal, what you have to do, if a binary number is given, we can combine 3 bits from LSB position. So from this side we will combine the 3 bits. So you combine 3 bits together. So what is 0 1 1? It is 3. Here 1 0 0 it is 4. 1 1 0 means it is 6. Here it is 0. So you can discard this one. So 643 is the answer for octal number. Next we have to find what is the equivalent decimal number. So that we can find from the binary number directly. So binary number is here. Find the weighted value for each bit. 2 power 0, 2 power 1, 2 power 2. It continues like this. So this bit is 2 power 8. So 2 power 7 ends here. So it is 2 power 8. 2 power 8 is equal to 256. So let us multiply all these things. 1 into 256 plus 1 into 128 plus 1 into 32. Then again you have 2 and 1. So if you add it, you are getting 419. So the equivalent decimal value is 419. So if you like the video, do subscribe to Read Electric Vehicle channel, and if you have any doubts, you can mail me to this email ID readelectricvehicle@gmail.com. Thank you.